All right, we are skipping ahead to lesson 7 of unit 7 today. We're going to talk more about the normal distribution, which we had started last week. Remember, that's the bell curve. Particularly, we're going to look at how to find different proportions or percentages or probabilities. So to do that, we're going to use this online calculator here. So your lesson notes is to simply bookmark this calculator. And the examples today are going to be me showing you how to use this calculator to solve problems. So the lifespan of light bulbs is approximately normally distributed. Some statistics about lifespans of two different types of light bulbs are listed. Notice for each light bulb here, they give us the mean and the standard deviation. Since we learned about on last week that the normal distribution is based off of entirely the mean and the standard deviation. So let's take a look at number 1. Estimate the proportion of LED bulbs that are expected to burn out before getting within 1 standard deviation of the mean, before 2070 days. So with that in mind, let's go to our calculator, the normal calculator that I shared with you. Okay, so we are talking about LED bulbs. So we're going to put in the mean and the standard deviation for LED bulbs. So the mean is 2300 and the standard deviation is 230. Okay, and we want to know the proportion that are expected to burn out before 2070 days. So before 2070 days, before would be a fancy way of saying below. So we're looking for below 2070 days. So before or below 2070, we will calculate. And notice this is our probability right here. So our probability or our area under the curve will be 0.1587. Okay. I'm going to skip ahead to number 3 since that also has to do with LED bulbs. So estimate the proportion of LED bulbs that are expected to burn out after getting more than 1 standard deviation greater than the mean. In other words, after 2,530 days. So when we do that, okay, since we're talking about LED bulbs, the mean and the standard deviation is going to be the same. But now we're looking for after 2,530 days. So that's going to be above 2,530. So I'm going to choose above 2,530. Notice I get the same answer. That is just a coincidence. So 0.1587. What's the next LED bulb question? It looks like number 5. Okay. Estimate the proportion of LED bulbs that are expected to burn out in the interval between 1 standard deviation less than the mean and 1 standard deviation greater than the mean. In other words, between these two values here. So again, we're talking LED bulbs. So mean, standard deviation are going to stay the same. But now we want the proportion between. So I'm going to go to between, choose between 2070 and 2,530. So between 2070 and 2530, there's our answer, 0.6827. Okay. Our next LED one is number 7. So now we're looking for between 1,840 and 2,760 days. Okay. So LED, same mean, same standard deviation. We're going to go to between, excuse me, we're going to go to between 2,000, what are we doing? Between 1,840 and 2,760. And there's our answer here, 0.9545. So, and then looks like our last one for LED is number 8. Now we're looking to burn out in the interval between 1900 and 2100. So same mean, same standard deviation between 1900 and 2100. And there's our answer, 0.1513. Okay. Let's go ahead and answer the questions about the incandescent bulbs. So estimate the proportion of incandescent bulbs, number 2, that are expected to burn out before getting within 1 standard deviation of the mean before 90 days. So incandescent bulbs are going to have a different mean and standard deviation. So notice up here it says our mean is 100 and our standard deviation is 10. And we want to know the proportion or the probability before 90 days. So that would be below 90. And notice we get 0.1587 again. Okay. Let's jump ahead to number 4. Estimate the proportion of incandescent bulbs. And we want to know after 110 days. So same mean, same standard deviation. Now we want after or above 110 days. And there's our answer, 0.1587. Okay. Let's go to number 6. Estimate the proportion of incandescent bulbs expected to burn out between 90 and 110 days. So again, that will be between 90 and 110 days. Okay. 0.6827. Okay. And then our last one is number 9. Estimate the proportion of incandescent bulbs that are expected to burn out in the interval between 107 and 118 days. So that would be between 107 and 118 days. Same mean, same standard deviation. Let's calculate 0.206. So the answer to number 9 is 0.206. And that is how you use this calculator to figure out these proportions. Okay. Your cool down will be a couple of questions just like I just did here. So that is it for lesson 7.